Okay, so we're live.
Okay, coolios.
So, and are you just observing us, or do we need to, like, is there something else we need to be doing?
Oh, I think she froze.
Oh.
Should we wait or check restarting or something?
Yeah, let's just start, because I don't want to be here all night. Not to be rude, but...
Did you guys already do the homework on the my math lab?
Not yet. Have you?
Yeah, I'm trying to hurry up because my wife wants to do something this weekend, and I'm still trying to figure out if I can do everything. So she's gonna start beating me soon.
He's like, I can't handle this anymore.
Yeah,
You're taking me out on Saturday.
oh, she's yelling at me. She's like, "You're lying."
Should we just?
Let's just start.
Okay.
Yeah.
Alrighty. So solve the triangles with the following information. So they give us the angle and the two sides.
Are we? We're allowed to use notes on these, right?
Yeah.
For the extension problems, yes.
Okay.
Right.
Just
So
to make sure, because the math, the homework, the fourth part of the homework is filled with all these kinds of things.
Which part?
The fourth, my math lab.
like the last assignments.
Yeah, the very last one. It's the law of cosine.
Oh yikes!
And it's actually no, not the law. Well, part of that, and part it's like another one. It's called the Heron. It's Heron's area formula.
Oh.
Oh, you guys are gonna love that one. Actually, both of those laws are just insane.
Really?
Yeah. But once you get to do them, because it's basically from when you start to when you finish, it's just all problems that you use that with, and it actually teaches you how to do it a little bit different every time. So it kind of gets you thinking.
Okay. So it takes a while to do the homework, you're saying?
Yes. Yeah, I'd say yes.
Okay.
Hi guys, sorry, my internet just stopped working for some reason.
You're good.
It's fine.
Okay, so the first part, so they give us the angle and the two sides. Then you're supposed to solve the triangle.
Yeah.
Okay.
Yeah.
So I'm assuming for this one, so if you're given the angle A, and then you're given the side that's correspondent with it, and then you're given C, which C would be the hypotenuse, right?
I think so.
Okay, so wouldn't the idea be to make sure that either the sine, cosine, or tangent of that angle equals like the, what's the word I'm looking for? You know how like the sine of A or sine of something is opposite over adjacent?
Yeah, so
are you solving the first problem? Sorry.
Yeah, the extension problem.
Yeah, the first extension.
Okay, so what do you want to say, Monique?
Oh, I was just I was going to say, I think, would it be possible to find the other angle, and then if it adds up to 180, it would...
Oh, yeah.
You're saying? Yeah, Mitchell?
Yeah, exactly. The thing is that you can use tangent because it's not right triangle. You don't know yet if it's 90 degrees there.
Right.
Yeah.
Okay.
There was one of the... I'm trying to find on the homework. I took notes on it. We used the law of cosines. And so, because we're given two of the angles, on that one, actually, Let me think. Let's grab it. So the law of cosines. Let me see if I can put it down in the chat for you guys. Hold on. It's basically this right here.
So this is my thought. What I was saying is earlier. So you're given the angle. So if you're to do, so A is the opposite, and then C is the hypotenuse. So that would be the sine of 39.6 equals 3.7 divided by 18.4. And if those don't equal each other, then it wouldn't be a triangle.
Okay.
That's just my thought. That's just like what my or not. I guess my theory would be. But do you understand where I'm coming from?
Yeah.
So I did that. So I did what I said, sine. So I did the sine of 39.6, and that gives me 0.6374, and so on. And then if I did 3.7 divided by 18.4, it gives me 0.2018. So they don't equal each other. So my answer would be that you couldn't solve the triangle.
So it's not a triangle?
Yeah.
But the angle alpha is the opposite. It's the how to say it? So there is an A side, and the opposite angle of it is alpha. So meaning that the hypotenuse will be the C value, 18.4.
Right.
So you're dividing it by 18.4, right? Not 3.7.
Yeah. So I did 3.7 divided by 18.4 because it was the opposite over the hypotenuse, and that's what sine is.
Well, how do you know that the next angle is 90 degrees?
That's what we don't know.
Yeah, so you're like pretending that you're drawing the height of it?
I'm trying. I kind of get what you're saying, but at the same time, I'm not. But I think I'm getting what you're saying. Is that we don't know it's a right triangle, so my theory wouldn't exactly work.
Yes, exactly.
Okay.
We have to check what the other angles are first.
Right.
In order to apply those kind of stuff.
Okay, so Antonio, you sent the law of cosines, right?
Law of sine?
Yeah.
Oh.
So.
Yeah, but I'm trying to figure it out. I don't think we might not be able to use that on this one.
Yeah, because it says the triangle's an oblique, but we don't know what it is yet.
Yeah.
And if you want to use law of cosines, you have to have two sides, and the angle between those sides. But we don't have. We have just the angle, and then the side, and then the opposite side. So we can't use law of cosine.
Can't we use that a squared plus b squared equals c squared? I don't know what it's called. I can't remember.
Theorem?
Yeah.
Well, in order to use that, we have to have. Well, actually.
Because we have a and c.
Yeah. Yeah. True. We can use that. Yeah.
Well, we just need to solve for b squared.
Kind of complicated, but we can use that. Yeah, I got what she said.
Matthew, we can't hear you.
So what I got was approximately 18.02.
That's what I got.
For B.
For B?
But Isn't it just the tenths? Don't
Yeah.
we just round out to 1? So it would just be 18.
18.02.
Or I just kept the O2 because the other answers were in the hundreds.
Oh, okay. So just 18.
Yeah, so we can just do 18.
So B equals 18.
Okay, and then now we can find the angle, right? Or we can find, another angle.
Yeah. We should be able to do have B, so it would be beta.
Yeah.
This stuff confuses me so.
So if we were to find the beta angle, would it be, so you would use B, so it would be the opposite, right? Because it's a cross.
Yeah.
And then we could use the hypotenuse one, right, again? So that'd be the sine, so it'd be the, what is it, the arc, is it the arc sine? No. It was the sine of 1, right?
Let's see what that's called.
I think you, wouldn't you do arc or cosine?
Well, since we're doing opposite over hypotenuse, that's what the sine is, because it's SOHCAHTOA. So is opposite over hypotenuse.
Okay.
So I think I remember yesterday, remember we were trying to find an angle, we have to use the sine to the -1.
Yeah.
Have you guys used the law of sines yet?
I'm not in the homework yet.
So on the
sources.
So on the homework, the law of sines is A over sine of A equals B. Well, sorry, maybe I just wrote it like this, but it's A over sine of alpha equals B over sine of Bravo equals C over sine of that Y. I don't know. Maybe that's just the way I wrote it. But if you take like the sine of that Bravo, just put sine of Bravo over the opposite angle, which is 18 here, and then you equal that to the sine of alpha, 39.6 over 3.7, and then you solve for the sine of B. You should get what that Bravo angle is. Yeah, just have it equal to each other.
Okay. The sine of 39.6.
Did anyone check out resources this week?
Yeah, I got the PowerPoints and stuff like that.
Mm-hmm. And do you remember what it was saying about SSA?
The side angle and side angle and
yes,
side.
Like figuring out how many triangles are possible.
I remember reading that. I just don't remember like the information about it.
Okay. So the very first thing you need to figure out if triangle is possible with this stuff.
Oh, so if we're given an angle side, that can't work because that's not an option, right?
I think you should probably look more if you are drawing like a height and then you have the sides and you're thinking if the height and did anyone find height? Sorry. it will be sine 39.6 equals to height over 18.4.
Sorry, say that again.
Sine of 39.6 equals to height over 18.4.
Okay.
Can you guys hear me now?
Yes, I can hear you.
Sweet. Okay.
So for the height, I got 11.7.
Yes. So what does it mean?
You got 11.7
Height.
for height.
Yeah, that's what height was.
So it's saying sine of alpha equals pi over c. So c.
I think there's something in the. I think there's something somewhere that it says if you have a certain side higher, like bigger than another one, it's not a triangle because it's not possible.
Exactly.
I think it involves the height, but I can't remember where it is.
It is in the week 8 lesson 3 for resources as a PowerPoint.
Okay, I got it here. I just gotta open it. I remember seeing it somewhere.
So let's think about that. We have a side which is 18.4, then the other side is 3.7. And then we found out that the height is, height, I don't know, I am always saying height. It's 11.7. And then it says that this side is 3.7. So how is it possible that this side is less than the height? So if it is less, it at least should be 11.7. It can be like less than that, right?
So does that mean it can't be a triangle?
Yeah, that's why there is no triangle with this stuff that they gave us.
So we just need to find the height first, and then
and then see if
that makes sense or not.
Mm-hmm.
Okay.
Yeah.
Okay.
So we can just skip this one and say that there is no triangle. We can't solve it.
Yeah.
Okay. So then the next one, the beta is 28.6, A is 40.7, and B is 52.5.
So for this one, I guess, could you use a law of sines like you were saying earlier, Antonio? So if you did, what was it? So since we have beta and side B, it'd be 52.5 over the sine of 28.6 equals 40.7 over the sine of A.
Exactly.
All
Okay.
right, we say that.
By the law of sines is sine over the side equals to sine over the side, but I'm not sure if it will change anything. So I feel like it's fine.
So it was 52.5 over the sine of 28.6 equals 40.7 over the sine of B. Or sine of A, sorry.
And we need to find sine of A.
Yeah. So what I got was 21.8 as angle alpha.
That's what I got.
Yes.
Yeah, that's what I got too.
And then since we have two angles, we can find the other angle if we just subtract 180, or if we do 180 minus those two sides, or two angles, sorry. 180 minus. So the other angle comes out to be 129.6.
Mhm.
And then now we're just left with finding side C, right? Or sine C. So we would just use the law of sines again to solve for that C side. So we could use 52.5 again over sine of 28.6 equals C over the sine 129.6. And then that gives me,
I got 84.5.
yeah, that's what I got as well. Okay, so
Is that degrees or is
what was that?
that degrees or is that just the length of the side C?
That's the length of the side.
Okay. I got 84.5. I just didn't know what the.
Yeah, since we're finding the side, it's going to be in the whatever.
Unit, but it doesn't tell us, so it's
Yeah.
Okay. Okay.
All right, everybody follow on that one?
Yeah, I follow that one.
Okay. So the next one, for angle Y, is going to be 32.7. The side across from it is going to be 28.6. And then the B side is going to be 37.5. So we would just keep using these laws signs. So then we have 26 or 28.6 over the sine of 32.7 equals 37.5 over the sine of B. Right, and then so I got 45.1 as angle beta. Did everyone
I
else
did
get
not
that?
get that.
You didn't get that, Monique?
No, let me try it again.
Wait, what did you get?
I got 45.1.
And this is for beta, right?
Yes.
Okay.
Okay.
Yeah,
I got
yeah, yeah.
40.
I got it too.
Okay, cool. And then, so now we have both of those angles, so we can find the other one now. So we do the same thing as 180 minus 32.7.
What about checking if there is second possible angle or a second possible triangle out of this data they gave us?
There's another possibility.
Yeah. And to check that, it's pretty simple. You just subtract 180 minus the angle you found, which will be what?
So 180 minus 45.1 comes to 134.9.
Yes. And then we know that they gave us the angle 32.7. If you add them together, you'll have something less than 180, meaning that there is a possibility of this third angle, meaning that the second angle is also valid.
Oh, okay.
There are
That
two
makes sense.
Oh,
If you would have found this second angle and then added to the angle they gave you, and it was something like 200 or something, it means that it's invalid.
Oh,
wait,
okay.
so would the second angle be 134.9 then?
Exactly.
Oh,
Exactly.
okay. Oh, okay.
Then you have to solve like totally separate triangle with.
But we still have to solve for both triangles. We don't just
Yes,
do
exactly.
the second one. Okay.
Okay, so that makes sense. And so then, so I guess to find the other possible one, I guess we would first do, we could do 180 minus 32.7 minus 45.1. So that would give us the possible of the other one being 102.2, but then there'd be another possibility. So you have to do 180 minus 102.2, and the other possible angle would be 7.8.
97.8.
No, there cannot be more than two possible triangles. There can be a maximum of two.
Oh.
So you have only two possible angles, 45.1 and 134.9.
Oh, okay. Okay, so I get what you're saying. So in this case, so do you guys understand that?
Not really.
So you know how we found the 102.2?
Uh-huh.
So that's the possible angle with if we add the 32.7 and the 45.1. So the other possible angle that it would be, we would have to do 180 minus 32.7
Minus 45.1.
what was that?
Minus 45.1. 180 minus 45.1.
So 134. I thought we already did that one.
Yeah. That gave
134.9.
us 102.2, right?
Yeah.
So now the other one would have to be, we'd have to do 180 minus 32.7 minus 134.9.
And we get 12.4.
Yes, that's what I got. So those, because the 32.7 is going to be one angle for either triangle. Like that's a like permanent angle on there. Does that make sense?
Yeah.
Okay.
Does that mean we have to do sides for both triangles as well?
Yeah. So
we have to find two sides. Okay.
So what we would do, so we would keep the original angle. So we would do 28.6, which is the side C, over the sine of 32.7. And then for the opposite side, we would have to do, what are we solving for? A over the sine of, first we'll have to do 102.2. Does that make sense to everybody?
Yeah, I got it.
Okay. So if you solve for A, so one possible side for this one, I got 51.7. If that's what everybody else got.
I got 51.7.
Okay, and then now to do the other side, we would do the same exact thing, but for the sine, it's going to be sine of 12.4 instead of 102. Does that make sense?
Yeah.
Since we have two possible angles right there.
Yeah. And then
So we're
Okay.
keeping the 32.7 on the one side.
Yes.
Um, 11.4.
That's what I got. You guys are solving for the A on the other triangle, right?
Yeah. So we got 51.7 on one, and then I just got 11.4. You guys got 11.4, right?
Yes.
That's what I
Okay.
got.
Yeah. Okay, and then if we check, so and the angles A can be 12.4 or 102.2, so that's right. The other angles could be 45.1 or 134.9. Okay, so that's right. And then the two sides could either be 51.7, 11.4. So we got both those. Coolios.
Did you check the other two that we just did too?
Oh yeah. Yeah, so the first one, so the first one was correct, no triangle.
Okay.
And then the second one we had, so A was 21.8, that's correct. Y was 129.6, and then C was 84.5, that side. Yep, that's right too. Sweet, we're killing it, guys.
I'm not. I'm struggling through this section so hard.
I mean, we're getting it all together though. That's the thing, is that we're
Yeah.
Like, my brain does not work like this. I don't know.
No, I gotcha. Okay, so the next one. So one of the types of application problems for the law of sines is the bearings of an airplane. The bearings of an airplane is from the north in the clockwise direction. It can also be written using the pole and direction from the pole. North 32 degrees west from the north pole, 32 degrees in the west direction. Answer the following question, part 2, involving bearings. So one other concept that is necessary in answering bearing questions is the idea of alternating interior angles that are congruent. Given two parallel lines, the alternating angles among other angles are congruent. For the image below, A equals B because they are alternating inside the parallel lines.
Okay.
So what's the question?
I don't think that's a question. I think we're just supposed to move on to B.
That's what I was saying. It's just like, oh,
Just telling us information.
yeah.
Okay.
But I mean, that's right, because they're parallel lines and they're complementary angles, so they're going to be,
That makes sense. Yeah.
or alternating interior angles. So, so next one. So, a friend offers to take you on a plane ride from Rexburg, Idaho, to pick up another friend in Idaho Falls, and then go to Jackson Hole, Wyoming for lunch, and then return home to Rexburg. You leave Rexburg on a bearing of south 13 degrees west. When you leave Idaho Falls, you head due east towards Jackson Hole. It is 91 miles from Idaho Falls to Jackson Hole. You're having a delicious meal in Jackson Hole. You return home on a bearing of 290 degrees. What is the total distance you have traveled on 3 legs of the trip?
Oh my word.
This will be interesting.
All right.
Well, first thing we need to do is figure out the angles.
Yeah. So it's gonna be like a triangle root, right?
Well, I think you want to draw that out. So the first one would be
So you want to draw the thing out on the top. I think we're supposed to draw a bunch of parallel lines, 3 different parallels, I think maybe 2 sets of parallel lines. One that make up a triangle, I think. Right? So you make a set of parallel lines, and then you make a line across it, and that bearing would be 13. And then so the congruent angle would be 13 as well. So you have the inside, part of the inside of the triangle, right?
So like you're saying building and 13 and then 13 on the other side?
Yeah. So I wish my camera worked on this computer. That's really hard to explain.
Wait, so did Monique draw it right then?
Wait, hold on. Let me look at it. Yeah,
So I
like
did
that.
13 on that one and then
And then
13 on the inside.
yeah, and then you do it again, but you draw. I drew it so it was perpendicular to those parallel lines. So to make the rest of the triangle, because you're going somewhere else at a bearing of 70. So it'd be like, so it's kind of like drawing a tic-tac-toe board, but.
So like.
Yeah.
That.
Yeah. And then
the other side.
Yeah, and then I think that's all the or wait, no, 290. But I did 70 because you did 290. Because 360 minus 290 is 70.
Will you hold that again, Monique, real quick? Sorry.
Sorry, I didn't know where we got 70. He just said 70, so I put it on there.
Well, yeah, no, it's because you're going at a bearing of 290, which is really wide on the outside. And so you'd be, so you draw it out, and all you have left is the 70 inside next to the 13. I don't know where to go from there. I think that's, I mean.
Well, so Monique, if you hold your paper up again. So I think
would this length be 91 since it says it's 90?
Yeah.
So you start at, so from the edge of the third, wait, hold on. Continue what you're saying.
Me?
Yeah.
Okay. So since we have 2 parallel lines, what we can find is that angle that's on the other side of that bottom 13. Since they're congruent, that whole angle right there is going to be. Oh no! Wait. Ah, crap. I just had this in my head.
So we have an angle because it's 91 miles to Jackson Hole.
Yeah, but you go to Idaho Falls first. So that from that line that you have right there is from Rexburg to Idaho Falls. That's what I'm saying, because you go from Rexburg to Idaho Falls first.
Okay, so you're saying she goes from the left to the right and then up and then back. Is that what you're saying?
Left to the right and then up and then back.
So,
yeah,
so
I was just thinking down, but you could go up or down. Either way works.
Well, if we're putting 91 miles on the bottom,
yeah,
it would. So where the bottom 13 angle is, that would be, where would that be? Is that Idaho Falls or is that Jackson Hole?
The bottom 13 would be Rexburg.
Okay, so Rexburg is the left.
Yeah, Rexburg is the left, and then the one with the 70 and the 13 is Idaho Falls. Yeah, Idaho Falls, and then we got to do another line to Jacksonville. So the 91's on the bottom, so you have a line on the bottom that's 91, and then you have a line from the original 13 to the one where we added 70. The one Monique had at first. If I'm making sense. Am I making sense at all?
Yeah, keep going.
And then you have the line connecting the 13 and 70 to Jackson Hole. So that would be so it'd go Rexburg to Idaho Falls to Jackson Hole. So it goes from left to up, right, up and to the right, and then it goes, because you have a straight line at the bottom that's 91. Because we know that's the distance from Rexburg to Jackson Hole. And then you would, and so we have that line that the first line that Monique drew was Idaho Falls to Rexburg, and then you connect the lines from Rexburg to Idaho Falls, and then Idaho Falls to Jackson Hole. So you finish the triangle, right? I'm gonna.
Do you have that written, Monique?
No, I'm still in the same. I got that.
Oh wait. Oh no. Okay. No, you have it written out. You have it written out. Hold it up again. I'm just trying to explain that. Yeah. So we have that. That's the triangle. See that inside part? I think that's the triangle we're trying to work with.
Okay.
And the right one, I think that's the triangle we're trying to work with. So we're trying to find the inside of that triangle.
Yeah, the problem with your drawing, there is like mistakes. So south 13 degrees west, meaning that the angle goes from south towards west. It is explained earlier. So if you see anything, here's west, east, north, south. From
north, south, east, west.
From south to west, because it is it says south 13 degrees west. So starting from south, going to the west, this is 13 degrees. So your very first line goes like here. Here's 13 degrees because because this one is south and this is one is west, so it's going here. Okay, so it's not the whole triangle, it's just from south to west. And this is from the Rexburg. Then he's going to Idaho Falls.
Okay.
We don't know. And then he turns to the Jackson. And it says on the bearing of 290. And if you read a little bit upper, it says bearing means from north going clockwise. So we have here, let me draw. So here's north. So do you see this? From north going clockwise 290 degrees.
Okay, so it turns.
So the outside angle is 290, right?
Mm-hmm.
And then we have here this one, and this one is 90 degrees. So
because of the bearing, correct? Or because of the northeast, southwest?
yeah, but they said just with a bearing of 290. When they're saying with a bearing, I mean it goes from north clockwise.
Okay.
But whenever they're saying like southwest, northeast, meaning that from the first one to the second letter, right?
Right.
And then here's 91 miles because he was going from Idaho Falls to Jackson, 91 miles.
Okay, so that's what we're working with. So what we can do then first, so if that hole, so the Jackson hole, if that's going to be 290, we know that the rest of that angle, that little angle right there, is going to be 70, right? Because it's going to complete a circle and it's going to be 360, correct?
Exactly. The one that is outside of the angle, right?
Yes. So the one that doesn't have a circle around it. Yeah. So right there.
So what is the angle of the triangle then?
Yeah. Does that make sense, guys?
Yeah.
Oh yeah.
So then
And if it's 90, then it's the inside's 20.
Yes, exactly.
Because it has to add up to 180.
Well,
So
because
it's
it's the right angle, so it's going to be 90 degrees.
Well, that I was just taking the whole. Never mind. I'm looking at it differently. But yeah, it's 20.
So then it just goes back up to the starting, right?
Yes.
Well, now you know that the 20 is congruent with the outside angle because you have the hold on.
Well, we know the one angle now has to be 77 and 13 because it's a right angle.
Yeah.
Yes, because they're interior alternating angles.
So that'd be 83 is the top one in total.
Yeah.
Exactly.
Okay, and then the last one would be 77 because that's all that's left in the 180.
Yes, because if you did 180 minus 20 minus 83, you're left with 77.
Exactly.
Okay.
So then if we have all the angles now, and we have one side, then we can use the law of sines again, right, to figure out the other sides?
Yeah, I think so.
What we would do is 90, so it would be 191 over the sine of 83 equals, and then we'll do the side across from the 20 degrees. So it'll be, we'll just call it A over the sine of 20. And now we're just solving for A, the side. So for that one, I got 31.3 or 0.4.
For the side?
Yes.
I did not get
What did you get? What you...
I didn't get that. So it was 91 over sine over 83 equals A over sine of 20.
Yes.
I got 31.6.
Yeah, I got 31.6 as well.
Darn. I apparently can't use a calculator today, so I got 31.357. So yeah, 31.36.
Uh-oh.
That's what I got.
No, you
Yeah.
got two.
So are we rounding to the tenths or the hundreds?
What did I do wrong?
All the other ones were good just doing the 10th. So.
In the answers, it's to the hundreds.
To the hundreds? Okay, so we keep it 31.36 then.
Okay.
All right, so there's that side, and then we can do it again to solve for the other side. So it'd be 91 sine of 83 equals, and then we'll call this C of sine of, and then this angle would be 77.
I got 89.33.
Mm-hmm.
That's what I got as well. Alright, so we have all that. So the question was, what is the total distance you traveled on 3 legs of the trip? So you would just add all the sides up together, right?
Yeah.
So I got 211.69.
Mm-hmm.
Yep, that's what I got. And if we check that, yep. Yeah, everything looks good.
Oh man, okay. We earned that one.
Yeah, we did.
That one.
Thank you for helping us out.
I know.
Much.
Is this painful for you since you're like know how to do this? You're like, come on, guys.
I don't know. Not that painful.
You're kind of used to it.
Yeah.
Okay, who turned in the quiz last week?
I did.
Yeah. Matthew, have you turned in quiz lately?
Not lately, so I could do
You
it
want to do it this time?
Yeah. Hold on,
And then we'll circle
let
back.
me just get a new piece of paper so I can. Although I don't know if I could scan it tonight. If I just send it in tomorrow, would that be all right? do you think she'd be fine with me sending it in tomorrow, as long as we turn in the video tonight?
Yeah, because it isn't due till Saturday, right?
Oh,
Yeah.
that's right. Yeah, so I'll turn it in tomorrow.
Okay, yeah, and then just send us a text when you scan it or whatever.
Okay.
Or yeah, do the Google chat.
Yeah, sounds good.
Okay, cool.
That's wrong.
Alrighty, so instructions. All right, so explain why the expected response of arc sine -1/2 is negative pi over 6 and not 11 pi over 6. So,
I know this one.
yeah, we were talking about this one last night, right?
Yeah, I think this is what we were talking about, where it has to be in that quadrant.
Yeah, because the arc sine was like to the -1, right?
Yeah, and it has to be between 0 and 90 degrees.
Yeah.
Between minus pi over 2 till pi over 2. This is the range.
Yeah, the pi over 2.
Oh yeah. So it has to be in that first quadrant. So how do we write that again? Or how would
I don't know the correct words for it. That's just how I remember it. I don't know if there's like a law that goes with it. I just know that it has to be in between that side.
Is there a law to that or no?
If you just write that, I think if you just write that it has to be between the quadrants, then it should explain why it's in that quadrant, and then just say that it matches to that.
The complementary angle within that would be the same thing.
Yeah, I think that's what you were explaining yesterday, right, Monique? Because you're talking about that.
And for sine, I mean, if it was cosine, it goes through, like the whole 180. So, sorry, that's just how I remember it.
No, I get what you're saying. So, do you understand how to write that, Matt?
You want to
interpret?
Yeah. Interpret. Sorry, I was grabbing a new piece of paper, so I missed half of it.
Oh, we were just saying it was like what we were talking about last night, where it has to be between 0 and 90 degrees, which is pi over 2. So if it's in the negative quadrant, you look for the complementary angle inside that quadrant for the arc sine. It's negative because you're looking for the inverse of it. The inverse of whatever that angle is within that quadrant.
Okay, so you're just looking for, because it's negative, we're looking in the same quadrant. I could just write with that.
Mm-hmm. Well, because sine of -1/2, I think, is in quadrant 3. But since it has to, you have to look for it in the quadrant between.
Fourth quadrant.
Oh, okay.
It's fourth quadrant.
Mm-hmm. And the arc sine is defined in the fourth and the first quadrant. And the question is asking why it's not 11 pi over 3, which is in the fourth quadrant, but it should be minus pi over 6. Does anyone remember what the range is of inverse sine?
The range of sine?
0 to pi over 2? Or pi over 2?
No, the range of sine is from...
Oh, 1/2 to 1/2? No.
No, it's
minus pi over 2 to pi over 2, right? That's why it's defined in the fourth and the first quadrant.
Ooh, I'm trying to process that.
Sorry, you say that one more time.
Yeah.
So the range of arc sine is from minus pi over 2 till pi over 2, right?
Yes.
Now the angle, and that's why we say that arc sine is defined in the fourth and the first quadrant. But the problem with the 11 pi over 4 is that it goes through 0 till first, second, third, and then to the fourth quadrant. So it's going out of the range, kind of thing. And if you check 11 pi over 4 if you compare pi over 2 and 11 pi over 4, and you think if it is in the range, what would your answer be? I think.
So if it's out, that's why. So my idea, I must be doing it wrong then, because I just put.
No, you are doing it correctly. I mean, when solving the problems, you are doing it correctly.
I'm just not doing it right.
But like, not really understanding why we have to do that.
Okay.
I wish I had a paint or something. I'll just draw very quickly.
Sorry.
So here's minus pi over 2. Here's pi over 2. So this is the range of the arc sine from minus pi over 2 till pi over 2. Right?
Mm-hmm.
The arc sine is defined in the fourth and first quadrants. The angle of 11 pi over 3 is in the fourth quadrant. Right?
Yes.
Yeah.
But the problem is that the 11 pi over 3 angle is going outside, it's going like that to this point, going through the second, third quadrant to the fourth quadrant. Meaning that it's touching already the second and third quadrant. Meaning you should not, arc sine is not defined there. And if you look at the range of the arc sine is from minus pi over 2 till pi over 2, right?
Yes.
And then let's look at the 11 pi over 6 set. 11 pi over 6, yes. So try to think if 11 pi over 6 is within the range.
No, it's greater than.
Exactly, it's greater going outside of the range.
Okay.
Okay, that's why you have to take minus pi over 6. Because sine of pi over 6 will give you 1 over 2. But if you take sine of minus pi over 6, it will give you minus 1 over 2. Like,
Okay.
That makes
kind of it's the same thing, but you are staying within the range.
Yeah, so I guess what you would say, Matt, is just because arc sine, the range of arc sine is from negative pi over 2 to pi over 2, and 11 pi over 6 is greater than pi over 2, so it does not fit the range, but negative pi over 6 is within the range.
Okay. Okay, I got it.
Okay. Ready for number 2?
Yep.
Number 2, so the sun is far away enough that the object and its shadow will make a triangle that is a similar triangle with another object in its shadow. In geometry, we learned that if two shapes are similar, one is an enlargement of the other. This means that the two shapes will have the same angles and their sides will be in the same proportion. What information would be needed to calculate the height of the Ricks building, feet and inches, without actually measuring the building? After you list information needed, set up the problem as if you're going to solve it. Draw and label a picture and set up a ratio.
Oh,
Man.
so we'd have to think of a similar object, I guess, with a shadow.
So if you were to use a Ricks building, you could use like a tree outside, right?
Exactly.
So what it would be, so is you'd have one big right triangle where the height would be the Ricks building, so like the straight part, you know, and then you'd have the angle going down like this, all the way down to the ground, where the shadow meets, and then somewhere in that triangle you'd have another height, which would be the tree.
Okay.
So it's like
We're pretty much doing
yeah. Here, let me
like
see.
two different triangles within.
Yeah, let me draw.
Yeah.
Yeah, that's exactly. And the way you would label it is, so the first height, if you want to label this, Monique, the first height would be the Rick's building.
Okay.
And then the second height would be the tree.
Can we call Rick's building just R?
Yeah. So we can call Rick's building R and then tree T. And then for the other, so the bottom angle. So the bottom angle would be, how do they put, like would it be a capital T? Do you kind of get what I'm saying? Is I'm kind of like trying to write it in relation to like the alpha and then like the A.
Oh. So like from the Rick's building to the ground, that's a 90-degree angle, right?
Yes.
So mark that as a 90.
Yeah, so you can put a little box on the bottom.
Okay.
And then
Now that would be the same for that smaller triangle too then.
yeah, so the Rick's building would be a capital R, and then the angle across from it would be a little r.
Wouldn't the angles be the same?
Yes.
Yeah.
So like the angle from the tree would be the same from the angle of the Rick's building. Is that what you're saying?
Yeah.
Okay. I'm just trying to like label it so it makes sense, you know?
Mhm.
We just go back to the regular ones that we have, the A, B, C, and then alpha.
Yeah, should we just change everything to A, B, and C then?
I mean, we could do that, yeah.
Yeah.
And then I'll just make sure to write down Rick's equals A or something, and then B equals tree.
Or you can even just write Rick's building and then just like off on the side, but she'll know.
Yeah.
Okay. So do we need that middle line for the tree?
Yeah, because we're gonna need that for when we do ratios in terms of like if we were giving angles and stuff like that, we would need them to figure out ratios, you know?
Yeah, that makes sense. Okay.
So it said, what information would be needed to calculate the height of the Rick's building, feet, inches, without actually measuring the building? So what we would need is the angle. Is it the angle of the shadow?
The angle of the shadow and then how on the ground from the edge of the shadow to the building, right?
Yeah, how far I guess would it be a person standing right there? Like, could you say a person would be standing at that bottom angle so that they're like looking? Or no?
Yeah.
We could just say opposite angle of the Rick's. Right? Isn't that what we're talking about? The opposite angle of the Rick's?
Yeah. But
Yeah, and then from the edge of the shadow to the building.
yeah, okay, that's what it would be, the distance from the building to the end of the shadow.
Because that would give the both sides of the triangle.
Yeah, and then
we need to know the height of the tree, right?
yes,
Okay.
we need the height of the tree. And then you would also need to know that that there's a right angle in the triangle with the tree in it as well. Does that make sense?
Yeah.
Mhm.
so we have the angle from the shadow. Do we need the angle of that shadow?
The height of the tree, and
Height
then
Three.
right angles from building and the right angle from the tree.
Yeah, distance from the so opposite angle of the rigs, distance from the building to the end of the shadow, height of the tree, and right angle in the triangle with the tree.
Yes, because if you're given that, then you can find. So if you were to find, because if you're given the angle of the shadow, you can find the other angle at the top. Because since that's 90 degrees, you'd find that, and then all you would do is use the height of the tree and do the law of sines, and then do the proportions or the ratios, you know?
Yeah.
And I think that's it. So we have to set up the problem as if we were going to solve it. Draw and label a picture and set up as a ratio.
So the problem with your solution is the question is asking how can you know the height of the rigs building, not actually measuring, meaning that the question asking to make things easier, like to not do so complicated stuff. And you're trying to measure the height and then the angle. How are you going to do that, you know? They are asking you to compare two objects kind of thing and make things easier, not having to do all of this.
Right. So like you just said, is we would have to compare one object to the other and figure out what the ratio proportion is, right?
Exactly.
So that information that we would need would be the height of the tree and the angle of that shadow, like we were saying earlier, correct?
You wouldn't even need the angle because the angle is the same from of the shadow of the rigs and of the shadow of the tree is the same because it's sun. And
Oh, okay. So all we need to know is to find the ratio between the height of the tree and the height of the Rick's building.
height of the tree, height of the rigs building, and their shadows.
Oh, okay. I think that makes
Height of the tree over the length of the shadow equals to height of the building over the height over the length of the shadow of the building, kind of thing. Because the triangles are similar because they have 90 degrees here and then the same angle here, both of them, meaning that two angles are the same, meaning that their sides are proportional to each other.
Yeah. Okay. Does that make sense, Matt?
Yeah, so ratio of the height of the tree and rigs and the ratio between shadow of the tree and rigs.
Yeah, so what she was saying is the height of the tree over the distance from the tree to the end point, like the bottom right where the little angle is.
Yeah.
Equal to the height of the Rick's building over the distance to that same point.
Yeah. Can we just call that distance x? And then so it'll be, right? So in that equation, it'd be the height of the tree over x equals height of the rigs equals over height of the rigs over x plus another number.
You'd have to use like C or something like that.
Yeah, something like that. But that would be the equation we would use.
Yeah.
Okay.
And then you have the picture, right?
Yeah.
Okay. Okay. Does that make sense, Monique?
Yeah.
Yeah, it makes sense. I guess, but you'd have to still know some measurements, right? You couldn't do it without.
I don't think
Exactly.
we're looking for the exact measurements. We're just looking for the ratio
Oh,
here.
how you would find it? Okay.
Yeah.
You're just saying what measurements do
What
you
would
need to
you
know,
do? Okay.
and then you're labeling like some random letters to see
Okay.
the ratio.
That makes sense. Then yes.
Okay, so we're good on that one then.
I think
Yes.
so.
Okay.
Antonio, do you have anything you need to add? Or does it make sense to you?
I was thinking about it a little different. I followed you guys, but I was just thinking, if you draw, like I drew this triangle here, and it's not gonna make sense. I can assure you that. But if you draw this building, this Rick's building, and then I'm just curious, I don't know if it makes sense or not. If you knew the distance between the building and the tree and the height of the tree, then wouldn't you just need that distance, the height of the, that distance, and then we know that this is a 90-degree angle, and we would just need this this measurement of this angle right here, and you could basically figure out the height right here.
Yeah,
But
I'm following you on that one. I think that's
Yeah,
just
that makes sense. The only problem is to measuring the angle. It's kind of hard, and you will need to climb on top of that. I think it would be easier to just measure the height of the building itself.
yeah,
yeah. No, we get what you're saying, Antonio. It's just like that's just like an extra step to go, you know.
yeah,
But
yeah.
it's-
But
Good
I
luck.
got. Sorry.
No, I'm just saying that it's good logic you're using.
Oh yeah.
but you were following us, right?
Yeah, I understood what you guys said. I just was
Okay.
thinking a different thing as well. Sorry.
No, you're good.
I'm sure there's multiple ways to get at the same answer, but
So
But we are trying to find the easiest solution.
yeah.
I like to make things hard. So
All right. So
Okay.
next one. So the angle of elevation on the top of the Angel Morona and the Rexburg Temple from point X on the ground is 47.8 degrees. From point Y, 75 feet further from the temple, the angle of elevation is 36.5. What is the height of the Rexburg Temple, including Moroni? Okay, so what I'm assuming is that I think we're looking at a triangle like this, where there's two different points of angles of elevation.
Yeah.
it's
So-
one from Moroni, one from the top of the temple.
And didn't it give us one distance already? Yeah. So it the point X and point Y, and the distance between point X and Y is 75 feet.
From point Y, 75 feet further from the temple.
Yes.
So Y is the furthest point. So Y is all the way out
Yeah.
right there. Well, if it's saying it's 75 feet further from the temple, then that means from right here all the way to Y is 75 feet. So the whole distance would be 75.
Wait. Repeat that?
So it says from point Y, and then it says 75 feet. Oh no, you're correct. Sorry, you're right. So it's just like 75 feet further than X.
Yeah.
Okay.
So it goes to X. X is the first point, and then it goes 75. In between X and Y is 75. Yeah,
Right.
that gap right there is 75 feet.
Okay. Yeah, I was reading it wrong. Sorry.
You're good. You're good.
All right. So we know that so at X, that angle right there is 47.8, and then from the Y one, it's going to be 36.5. So if we have both of those, so we can figure out what the top two angles are, right? Because it's a 90-degree from the building.
Yeah.
So if we did the first one, so 90 minus 47.8. So the inside angle of that top one's going to be 42.2. And then if we do the other one, so it'd be 90 minus 36.5. That one's going to be 53.5. So we have all those angles. So now all we have to do is figure out the distance, right? Or do it. So we need to figure out the distance from X to the temple.
Wait, what if we hold on? Would those lines be parallel, or would they meet at the top of Angel Moroni?
No, they would be parallel.
They will meet at the top of the angel.
Oh, they would.
Because I'm thinking that's because you're splitting it into two different triangles. I don't think they'd meet at the top of the angel, because I'm just thinking about it in the way of solving. You'd have to be.
Yeah, it's like saying 75 feet further from the temple, the angle of elevation is 36.5. The angle is different. It's not 47.8. If it was 47.8, then yeah, the lines would be parallel. But the angle is different, and meaning that they're implying by that it's going to the very top of the Moroni still.
So what you're saying is that, Matt, is they're meeting at the top?
Yeah, because it's just like if you step back a couple of feet, then you'd see it at a 36.5 degree angle.
Okay, yeah, I get what you're saying now.
Because I was thinking about how to solve the bottom part, and you just wouldn't be able to do it with parallel lines.
Yeah.
And they can be parallel only if they're bent on the same angle. They can only, but it's not the same angle. The one is 36.5, and the other is 47.5.
Right.
Okay.
So we could solve for.
So it'd still be 53.5 and 42.2. But 53.5 would be the total, and 42.2 would just be the inside triangle.
And then you would find that little one by taking the difference of the.
Yeah.
Okay.
Which would be 11.3.
Okay, so that little one is 11.3. Okay, so then if we have all those, so then from there.
So guys, I need to leave.
All right.
Thank you for your help.
Yeah,
Yes, thank you so much. We probably wouldn't have made it this far this quickly.
Yeah, we'd probably be on still like the first question.
Yeah.
Yeah, just think about the problem you set up, and there is 90 degrees, and what do you need to find? Height you need to find, and then you have distances. You have adjacent over opposite over adjacent kind of thing.
Uh-huh.
Then you have like two of the equations, and then you'd have to solve it as a system of equations.
Okay.
Okay.
It helps, but
Oh, okay. I think I figured it out. Alrighty. So we have two triangles here. So we have a right triangle, and then we have an oblique triangle, that really skinny one.
Yeah.
So what we can do is we can use the law of sines to figure out the hypotenuse of this inside right there. So what it would be is we would take so it'd be 75 feet, or 75 over the sine of 11.3. equals, and then so that side would be called, we'll just call it A, over the sine of 36.5.
The problem with your solution is that you can use law of sines only inside of one triangle. But you're applying law of sines to two different triangles. Right?
So mine's not gonna
Wait,
work.
no.
Wait. Oh,
He's
wait.
only, he's only doing the oblique triangle. He's only doing the oblique
Yeah,
triangle.
we're just doing the.
Okay.
It's 75 over sine of 11.3 equals A, or the hypotenuse over the sine of, what did you say it was?
Sine of 36.5.
Okay.
I was doing it right?
Yeah.
Okay, yes, makes sense. Awesome.
Sorry, I didn't want to.
Yeah, sorry.
No worries. I mean, you're the expert here, so. So what that gives us is that's 227.67 feet.
227. What?
Is that what everybody else got?
Yeah, I'm still working that out. Yeah, that's what I got.
So that's going to be the length of this line, or where am I? Right here.
Oh wait, the
Why?
inside. I thought you meant the hypotenuse.
No, sorry, I meant this. So it's
Oh, okay.
Did that make sense though?
Yeah.
Okay.
And then what we,
Oh, go
Yeah.
ahead.
I was just saying what we can do is we can use the Pythagorean and get the third side, and then we have. Never mind. Hold on. I was thinking that through, and that wouldn't work.
So we can use the law of sines again, but so what we would do is, since this is a complementary angle, so this angle right here is going to equal, so these two angles are going to equal 180.
Yeah.
So we can find the angle of that, and then we can find this side, this outside one, using the law of sines again.
But we need to find height. We don't need to find any of other sides. We need to find height. We have the angle and we have the hypotenuse, and we just need to find the height.
Oh, well then, okay, so then if we have this one right here,
We just need the sine over height over.
we can find this bottom one, right?
Well, we are trying to find height, not the bottom.
But if we get the
Yeah,
bottom, we can get the height.
Yeah, if we get the bottom, then we can get the height, right? By using
Oh,
the
but we have the three angles of the.
We just have to use that 90 degree with that hypotenuse we found, and and we can get the height with the 47.8 degrees.
Yeah.
So we don't really need to do anything else.
47.8 will be height over the hypotenuse that we found, right?
Yeah. So what we'd have is 227.67 over the sine of 90.
Over the sine of 47.8. Sine is opposite over hypotenuse.
You could, I think you could do cosine 90 though, right? Right? You could do cosine 90, and what you do is you do cosine of, never mind.
Let's just do the sine.
Yeah, we're just doing the sine. I'm just trying to help Mitchell's thinking.
So if we did
227.67.
Over sine of 47.8.
If you use SOHCAHTOA, wouldn't the sine of this the height be how she was saying, the opposite over the hypotenuse? So it would be just the 47.8 over that 227.67. Or am I thinking of Or is that with the length of that?
No, I don't
Bottom.
think that was the right
So
one.
sine alpha is the opposite side of the hypotenuse. Sine alpha in our case is sine of 47.8. What is the opposite?
Opposite over.
Isn't it 227.67?
Oh, I think
Opposite side of the angle. So here's
Wouldn't it would be height.
would be height. And then over hypotenuse. Hypotenuse in our case is the side that is opposite to the 90 degrees angle, the side over hypotenuse, which we found previously, 227.67.
So do you have it? So you're saying you wrote it like that?
Exactly. And now it's super easy to find height.
Now we saw. Yeah, okay, that's how it is. We were making it a lot more complicated than we needed to.
Sine is opposite over height, cosine is adjacent over, opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is adjacent over opposite, or opposite over adjacent. Do you remember this stuff?
Yeah, the GHOA stuff. We just made it complicated because we were used to using law of sines.
Yeah, I know.
It is.
I get it.
Yeah, we
So,
used
got
to.
a height of 168.66.
That's what I got.
Yes.
Awesome. Yeah, I have to take off. Have a good night, guys.
Okay.
And that's it, right?
I think we're supposed
Yeah,
to
that
put it
should-
into... Oh, never mind.
That's just it.
Yeah.
Yep, I think.
Okay, bye. Good night, guys.
Thank you.
Bye.
Bye.
Okay, I'm gonna close this and then I'll put the link on the video on the chat.
And do you want me to submit the link as well?
Yeah, if you'll just do both. I think
Okay.
that's easier then.
I'll submit. I won't submit it till tomorrow, so I'll just message you guys tomorrow because I want to submit the paper and the link at the same time.
Okay.
I think they're two separate things that you do. So
Yeah, I know, but I'm just saying I think it'd be easier for her if we turn them because I think she grades them when we turn them in.
no, this is different than the quiz. That you can do whatever you want as long as you put them in and make sure to do the participation points.
Yeah, so I'll put in the participation points tonight. I guess since I'm putting in the points
Yeah,
tonight,
just-
then I'll turn in the video as well, and then I'll turn in the paper tomorrow when I can scan it.
Okay.
I just
Sounds
have to
good.
head on to campus to scan it. All right.
Okay, thanks guys.
Thank you.
All right. See you guys.
See ya.
Bye.